Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Dagster offers a new approach to building and running data platforms and data pipelines. It is an open-source, cloud-native orchestrator for the whole development lifecycle, with integrated lineage and observability, a declarative programming model, and best-in-class testability. Your team can get up and running in minutes thanks to Dagster Cloud, an enterprise-class hosted solution that offers serverless and hybrid deployments, enhanced security, and on-demand ephemeral test deployments. Go to dataengineeringpodcast.com/Dagster today to get started, and your first 30 days are free. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'd like to welcome back Artyom Keydunov to talk about the role of the semantic layer in your data platform. So Artyom, can you start by introducing yourself?
Yeah, thank you for having me today. My name is Artyom. I co-founder and CEO at Cube. I started Cube as an open source project in 2019, and then with my co-founder in 2020, we built a company around that to keep developing the open source project, but also introduced a commercial version, the cloud version of the Cube, which is called the Cube Cloud.
And do you remember how you first got started working in data?
I was just a software engineer, and I think as software engineer, you always work with the data. So at some point, when I started to lead a project, and the project involved collection of a lot of data, and we were building an interesting product the software was deployed in schools, and the kids were using software on a daily basis. And the idea was to train the software to improve, so it can learn from the kids basically based on their action and kind of adapt different exercises, challenges that were presented to them based on their previous input. So to accomplish that on a scale with all the schools, we had to build a big data pipeline. I think that was my first real data project.
As you mentioned, you started the Cube project a few years ago. That was at the early stages of what some people called the metrics layer, other people called the semantic layer, other people will call headless BI. I'm just wondering if you can just start, for folks who aren't familiar with all these terms and the ways that they fit into the overall scope of data platforms, data management, what the technical elements are that constitute a semantic layer.
Right. I think as we think about semantic layer as just a concept, an idea, it's been around for a long time. So if you look back at Business Universe or MicroStrategy, there's older generation of BI tools, they all had a semantic layer as part of it. Essentially, what semantic layer is a way that BI can translate the high-level analytical style of queries into the relational or tabular queries, right? When we move sort of in our UI in the BI, when we move with drag, like active users with a breakdown by states or country, the BI would generate the correct SQL and execute that SQL inside some specific storage. So that layer is usually always been sort of considered and called a semantic layer. In fact, business objects, they even had a patent for that for like 10 years, and MicroStrategy successfully defended against it. So the semantic layer as part of the BI, it's always been around. But then probably by the 2018 and 2017, a lot of people started to talk about the standalone metrics layer or standalone semantic layer. And the need for this mostly arose just due to the fact that we reached a point where we had so many different BI tools and data consumption tools that it was unclear what was the source of truth. And I think it kind of happened due to the fact that a lot of people wanted to democratize access to data. So, bring more different specialized data visualization, data consumption tools, but also cloud contributed a lot to that because it became easier to buy and use software than it was like 20 years ago. So a newer generation of tools like Tableau, Looker started all, but then we got like Mode, we got ThoughtSpot, we got all this like tools that were like, some of them were cloud native that a lot of organizations started to adopt them. And, like in later generation is Sigma, like you got, like Light Dash and all of this tools. So it's like the number is only growing. And at some point, data teams, they started to think, okay, we have so many different tools and places to define metrics, to define semantics, what should be the source of truth. And that's where like a lot of organizations and just in data community in general started to talk about headless BI, metrics layer, semantic layer. There were a few different names to call it. I feel like a metrics store specifically came to the picture because a few organizations, Lyft and Airbnb, if I recall correctly, they built internally software that they called metrics store that was sort of, like some kind of a semantic layer. And that's why a lot of people started to use metrics store. But I think that idea never really came to the market as a general purpose solution. So that's why kind of the metric store idea started to fade out, and it all kind of replaced with a more like universal semantic layer. That's what people are talking about.
And as you mentioned, the semantic layer is the point in the overall data system where you convert from raw information into some sort of contextualized business domain objects. And to your point, for the most part, throughout the earlier history of data systems, that was a dedicated component of the business intelligence system because that was monolithic. That was the canonical reference for anybody who wanted to go and explore the data. Now, with this disaggregation of the overall data stack, there are a larger number of consumers. Not everybody's using the same tool chain. Not everybody has the same frame of reference or the same context. And I'm curious how that has complicated the question of even being able to define what the appropriate granularity and scope of those business domain objects are, even beyond just the technical elements of being able to represent them in a system that can be viewed as the source of truth.
Right. Yeah. There are just the more data we have, the more data consumers we have, and the more need to consume data, that obviously increases the scale of complexity and around the data modeling in general. And I think there are like a few ideas, even orthogonal to semantic layer, kind of arised in recent years to address some of these issues. Like a data mesh is one of those examples, right? Like how do we maybe hold the knowledge of specific data modeling, metrics modeling aspects inside domain teams so they can model their metrics, they model their definitions, but at the same time keep the centralized governance. I think if we zoom out here and think about what is a problem here in general, is that it's always a balance between well governed data and a flexibility on the end of the analysis. So in some world we can theoretically model every possible measure and a dimension, every possible granularity, and present that to the end data consumer. And that would be ideal. The thing is that it's just not possible to do, right? It's always going to be something that is missing, some granularity is missing, measures, dimensions are missing. So it's always going to be some data modeling at the edge where like an analyst or like a business consumer, they work with data, they would need to do some last mile transformation, maybe to look at the data differently. I think that for the data teams and for the vendors who are involved in that process, the idea is how do we help to keep the balance between governance on one end and flexibility of the last mile analysis on the other end.
Before we dig too much into more of the technical elements, as you said, there was this flash in the pan moment of the metrics layer being touted as this separate layer of the stack. It needed to be a dedicated system. And I'm curious if you can give your assessment of the current state of the ecosystem, the state of the market, as to when and whether the dedicated technical layer is merited as opposed to it being a feature of one of the other components of a data platform.
Yeah, I think around 2018 to 2020, that's where we had the recent wave of ideas around headless BI metrics, store metrics layer. As I mentioned, I think the big driver was this just explosion of a different data consumption and the data visualization tool on one hand, and the fact that a few big tech companies, they developed an internal solutions and they found some success with this internal solutions. So they sort of that catalyzed the idea around the standalone dedicated metric stores, and a few companies were started to address this problem. I think overall, if you look 5 years or so later at the market, is that many of those companies, they not a not around anymore, or like they got acquired or they pivoted, they changed direction. So Cube is one of the few companies that is still kind of doing the semantic layer. And the general sort of idea moved a little bit from metrics store or metrics layer into the semantic layer specifically. And it's not only the change in the name, but it's more like understanding the place of that layer, the place of that technology, rather than being more like a catalog of the metrics. It now is being considered more a place to do the multidimensional data modeling, sort of universally for all these tools. I think the state of today is, as I see it, the place of the semantic layer is on top of the data warehouse. It's a fully virtual layer that doesn't hold any data. It lets you to develop, it lets data engineer develop measures, metrics, dimension aggregates, dimensions to some extent, although many dimension modeling can be done upstream in a transformation tool. So it's mostly measures, metrics, and relationships, and then expose these models to all data consumption tools. And by data consumption tools, we mean not only BI, but also applications, so data apps, right? It's embedded analytics and just standalone internal apps, different variety of apps. I think that currently, if we talk with the buyers, we talk in the market in general, that's what would be an expectation from a semantic layer, is a data modeling framework that supports wide range of the metrics modeling specifically and relationships with joins. It would be APIs that can support BI connectivity, but also would support apps connectivity and some sort of a caching layer as well, and some sort of a security layer.
In the case that you, and so as you mentioned, the semantic layer or the headless BI, you can use that as an additional modeling tool to be able to say, based on these upstream tables that I have, these are the queries that I want to run to be able to represent what does it mean for somebody to be a customer, or what does it mean for a purchase to be completed, or how do I calculate revenue, all of these business layer semantic objects that you want to be able to ask questions about. But also data warehousing as an overall practice was originally designed to be able to address some of those questions. And I'm curious how you have seen the idea of this dedicated layer for building these more conceptual domain objects off of the core factual information that you have in the data warehouse, how that impacts the way that teams think about the data modeling approach, data delivery, who is responsible for which elements of that technical versus semantic modeling, et cetera.
Right, great question. I think from an organization perspective, it's always usually data engineers who are working both on a transformation and a semantic modeling. It really depends whether, like organization has something like a data mesh where, like a different domain groups will contribute to specific areas. Cube is code first, as some other tools in a modern data stack. So I feel like with code first, you always can get this benefit of a collaboration because it's essentially just a pull request, right? If you wanted to add a new measure. So that sort of can enable the sort of a mesh architecture. I feel like a marketing embedded team that they want to contribute to marketing metrics specifically, right? And then central governance team is going to review that. But at the end of the day, it's data engineers, regardless how they structure it within organization. The other part of your question, as I understand it correctly, was like what goes essentially into transformation versus what goes into the semantic modeling, which is a big question always when an organization starts to adopt a semantic modeling. That's one of the first questions, is like, should we model that right in a warehouse and materialize it in a warehouse versus we should do it in a modeling? So the usual what we recommend is the usual setup is to do dimensional modeling in the warehouse and to keep your models sort of normalized, say in a more like a DBT oriented way. That would be, they would call it a staging models. So you get to a point where like you build your staging models where like they look more like a normalized entities. And then semantic layer would be the denormalization point. That's where you bring your normalized models to semantic layer. You start describe measures, you start describe relationships, and then based on these relationships, you're kind of starting to build your multidimensional data marts, which are denormalized. They potentially can contain multiple measures, multiple dimensions. They can all package together as a single kind of a data asset that's like a data mart, which is multidimensional, which it can look like a table, right? But it's essentially can be multidimensional. And then you expose them to different data consumption tools. You can design them differently. They can have one measure, and then it's just a set of dimensions that can be used with that measure, or you can have multiple measures inside one data mart and multiple dimensions. So I see both ways, sort of, and they like equally good. But the idea is that you do high level idea is that you do dimensional modeling to and normalization on the data warehouse level, and then denormalization and measures on the semantic model.
For teams who have already been building out a data platform, they have their warehouse, they've already done their dimensional modeling, they've got a business intelligence system where they've already done some of those semantic modeling, or even maybe they've built those MART layers in the data warehouse and they're just doing a one-to-one representation in their BI. What does the adoption and migration process look like for incorporating the semantic layer as that canonical source of access for being able to query and interact with those semantic domain objects from multiple different consumers?
Yeah, good question. So it depends on a sort of a surface of migration. So if you have only, for example, Looker as one of your major BI tools, and your organization is planning to move off to, say, Tableau and maybe start supporting Excel and maybe doing some embedded analytics, and at this point you starting to realize, okay, Looker is great. I like my LookML models, but I can use them only within Looker, right? So I need now to use all of these different data visualization tools. And that's where you probably need to have something like Cube, right? A standalone semantic layer, and migrate off the Looker to that tool. Migration from Looker specifically can be very easy, just because the LookML is code-based, Cube is code-based. We even have a code editor where like you can just migrate things. So I saw migrations like this. I would say like a smaller to medium scale, which can happen really quickly. On other hand, if we, like engage with organizations that has a lot of modeling in S-base, like, or even like something more modern, like a Tableau, but, like you still got hundreds of workbooks and a lot of like metrics are being copied across these workbooks. So that might take some time. I think on our end, in general, in any like a semantic layer vendor end, we can offer, a lot of like blueprints or just best practices on a migration, but depending on the size of the data, right, it sometimes can be longer, sometimes it can be faster. But I would say like migrating of the Looker to Cube, that's always been the fastest route.
Another question of the adoption process or the evaluation phase of whether and when to bring in this separate semantic layer. One of the use cases is that the semantic layer can act as also a means of providing caching and accelerating the response times from your warehouse. And I'm curious how the underlying warehouse technology impacts that overall calculus of maybe I'm using Snowflake, and so I need to make sure that I'm minimizing cost and minimizing load on that because of the pricing model, or I'm using a data lakehouse system, and so maybe I need to be able to respond to queries faster. In those situations, the performance benefits seem fairly obvious, but if you're in the situation of using a Druid or a ClickHouse, which is optimized for interactive query speed, how does that influence the ways that teams think about whether and how to incorporate the semantic layer as a separate technical component of their stack?
Yep, great question. Most of our customers on Snowflake, Databricks, BigQuery, and Redshift, and Starburst now. So I would say this where Kube adds most of the value, and around the caching as well. The ClickHouse and the Pinot, Druid of the world, I feel like they're mostly being used in a very like low latency, real time use cases, maybe to power LinkedIn feed, right? That's what Pinot was created for. So maybe less general purpose like analytics, but more like specific use case within organization. So that's why naturally we just see less of them. But when we think about the warehouse, caching can add two main benefits. One is it can speed up the performance, and second, it can save on the warehouse cost. I will just explain high level how caching works so we can understand this benefit. So the caching in Kube works in a way that Kube would execute a query that you want. It all starts with a definition of what you want to cache. So you wanted to cache usually a few measures and a few dimensions together, which we call a pre-aggregation or roll-up table. So that would be bigger, it could be smaller, you can have many of them in your application. So data engineers, they can design what they want to cache and what kind of pre-aggregation table they want to build. Now, what would happen is that Kube will generate a query in the background that will go into the data source, say Snowflake, and will run the group by query essentially, right, in a Snowflake to get all the data that needed for that pre-aggregation table. Then we will tell Snowflake to export it into some specific S3 bucket or like a GCS bucket, so essentially into some object storage. Then Kube will read from that object storage and ingest it into its own storage. Inside that storage, we will optimize it, we'll do like some magic to just make it faster, and then it will just remain in Kube storage. Now, in the background, we can keep going into Snowflake and refresh the data. We can make it incremental. So there's like a lot of different strategies how you want to refresh that pre-aggregation. But now as the data is inside Kube, the Kube has an aggregate awareness. The idea of aggregate awareness is that Kube can understand that a query can be served from the aggregate instead of the raw data. So we can just get it out of the aggregate and serve that query. So now when we think about, even without all the Kube optimizations, usually it's faster to query from the aggregated table rather than the raw data, right? So that's definitely a performance benefit. Now, on top of that, we do a lot of optimizations. Like we have a specific engine for top K queries, right? Which is very popular in sort of analytical workload. So that's why all the cache queries are usually faster than the data warehouse queries. Now, on the performance side, because you don't really need to go to your Snowflake anymore, you don't need to keep it running. So if all your aggregates needs to be refreshed daily, so you can just run Snowflake for 4 hours, maybe midnight to 4 a.m., and then you just suspend your Snowflake, and then all the queries during the workday, they will be served from the cache. So that's a kind of cost benefit, cost saving opportunity.
Now that the conceptual elements of the dedicated semantic layer have been around for a few years, there have been a few different entrants into the market, some of which are still viable, some of which have faded or been acquired and integrated into other components of the stack. I'm curious how you have seen the overall understanding of the purpose and application of this conceptual technical element shift and some of the ways that that has influenced the adoption and usage patterns of systems such as Kube.
I think it definitely feels like it's maturing. In earlier days, I would say 2019, 2020, at some point, it was a lot of excitement around the idea of the metrics layer, metrics store, but it was very unclear how to use that, what exactly it is, right? Is it a catalog of the metrics where people can collaborate and comment, like, oh, this is a nice metric, who created it? Like, can you tell me more about, like the meaning of that metric, which was more like use case of the metric store. And on the other hand, there was a headless BI with specter of that story that was more tailored towards embedded analytics use cases, more like, like how we built a data app. So it was a lot of sort of uncertainty about how the semantic layer should work, like what place it should take in the data stack. I feel like as we went through in the last few years, it sort of definitely matured in terms of understanding. So now when, like when I talk to someone at the conference, or, like just someone out in the world from a data community, that most of the people, they know about semantic layer and they understand what benefits semantic layer can bring to the table. So that definitely feels different now. We haven't touched that, but I think that's in terms of the use cases and the place of the semantic layer. Recently, more people started to talk about how it can help with AI-based stack, especially around the SQL generation to the warehouse. I think that was probably the most recent addition to, like a use cases that can be powered by semantic layer. But other than that, most of the core use cases kind of, like it feels like we are settling down on the use cases for the semantic layer specifically.
This episode is brought to you by Datafold, a testing automation platform for data engineers that prevents data quality issues from entering every part of your data workflow, from migration to dbt deployment. Datafold has recently launched data replication testing, providing ongoing validation for source-to-target replication. Leverage Datafold's fast, cross-database data diffing and monitoring to test your replication pipelines automatically and continuously. Validate consistency between source and target at any scale, and receive alerts about any discrepancies. Learn more about Datafold by visiting dataengineeringpodcast.com/Datafold today. And in the technical evolution of the Cube product in particular, since that is what you're most familiar with, but just generally the ways that people are thinking about the implementation and integration of the semantic layer, I'm wondering what are some of the most challenging engineering aspects of building the system in terms of ease of adoption, developer experience, but at the same time trying to balance these aspects of performance and ease of integration?
In terms of challenges, I think we have at least three big sort of complex challenges and complex areas of sort of, like deep engineering. One is what we call a SQL API. So essentially is an interface how Cube can be queried. So when we think about different data consumption, data visualization tools, how they can get data from Cube is through currently 4 interfaces: REST API, GraphQL API, SQL API, and MDAX. For example, for Tableau to connect to Cube, Tableau would connect to Cube as to Postgres database. So Tableau will just generate a SQL code for the Postgres, and then we'll send that SQL code to Cube. Cube will take that SQL, look at it, and create a new SQL code, the real SQL, based on all the data model, all the calculations that needs to be sent to Snowflake. Then Cube will send that SQL to Snowflake, execute it, and then send it all the way back to Tableau, right? So the big technical challenge is how we translate from that incoming SQL from Tableau into outgoing SQL to Snowflake, right? Because we need to design a SQL language. Essentially, we're building sort of a SQL parser, SQL planner, SQL analyzer that also can understand the multidimensional queries. So that's been a big challenge. It's our team is using a lot of math, cutting edge math here to like essentially rewrite the query from the multidimensional into the tabular. So that's been an interesting area of development. The other two big areas, one is essentially building our caching engine, because we want to make sure that it's fast. It's built on top of Apache Arrow Data Fusion, which is Apache Arrow implementation in Rust, but we added a lot of our own development to that. It's all open source too, so like it's easier to check it out. It's written in Rust, as well as our SQL API endpoint. And the final sort of the challenging part from engineering perspective is the data modeling framework itself. And how do you deal with things like fan outs and traps? How do you make sure that you can model different measures, build correct relationships, all of that? So that's a big piece of that. So I would say these 3 areas are the most technically challenging: SQL API, caching with Cube Store, and data modeling framework.
In terms of the developer experience, as you were saying earlier around the data modeling question, you would probably use Cube as the so-called MART layer, where in dbt parlance. And so for people who are maybe using dbt as their overall workflow, What are their options for being able to effectively treat Cube as that materialization transformation layer so that they can use a single interface for doing all of their modeling, but have the option of being able to split the underlying compute substrate across the boundaries of warehouse versus semantic layer?
Yeah, great question. We have a decent number of DBT users, so we've been thinking about that problem. How do we design the developer workflow so it's a very straightforward and streamlined process going from transformations in DBT into the modeling in Cube. The good thing here is that DBT is code-based first, right? So essentially we can kind of combine the two products because they code first. So what we build is essentially sort of a blueprint, but also a code integration between Cube and DBT. So what users can do is that once they build their staging models in DBT, we can bring them over to Cube through our Python library. So essentially, it can read the manifest file with all the models defined in DBT, and then based on these models, Cube users, they can create cubes. And cubes is the first layer in our semantic modeling. So we have cubes, which are usually like normalized entities. They usually being one-to-one mapping to staging models in DBT with all the dimensions. And then on top of cubes, users would define all the measures. Once that piece done, and dimension part is kind of happening automatically because you just bring in your definition over from DBT. Then you define what we call views on a cube side. A views is a denormalization point. And that's essentially just saying like, I wanted to take these 5 cubes, put them together as a data mart, and then expose it to the world. So views are more like outward representations of the data model. So that's how the workflow usually is happening right now. And many our users, they keep it in the same repo. So it's like DBT folder essentially in a Cube folder, and you can kind of first do your dimension changes in DBT and then kind of work on the measures related changes in Cube.
So when you were on the show about 2 years ago, I think at this point, I think you had just started the process of doing a big rewrite in Rust. I think that the original name was actually Cube.js because you were focusing on JavaScript as that execution layer. I'm curious how that evolution of the technical underpinnings of the project and of the product have shifted the overall scope and goals of the project and some of the ways that it has shifted your thinking about how best to manage this as a production ready, production grade project for people to be able to rely on, and some of the ways that you can incorporate additional features because of those performance gains.
Yeah, that's true. So when we only started Cube, we called it Cube.js because it was written in JavaScript with Node.js runtime, and our data modeling framework, it was JavaScript based. And when we were like releasing that, we thought like we either can call it a Cube or we can call it a Cube.js probably. And the reason to call it Cube.js was to try to minimize the noise, because if you just go and Google Cube, like you can find a bunch of stuff, but it's hard. It would be hard to find a new open source project. So what we did, we called it Cube.js. I think it helped definitely to to let people easier find that open source project, but it also created a little maybe wrong impression about the product in terms of it felt like many charting libraries, they have name GS in their, like they have GS in their name. So you think about chart.js, high charts.js, and all of that. So many users, many people from open source community, they were thinking about Cube as a charting library. So we thought maybe we need to get rid of JavaScript. And also at the same time, like when we started to think about getting rid of JavaScript in the name, we started to realize that we would need to change the data modeling language from a JavaScript to YAML and Python based, because in the data engineering community, you just have more people familiar with YAML and Python based workflows rather than JavaScript. So we kicked off that process. And the separate stream was we kicked off the process of rewriting or like doing some changes to the code base, going from a JavaScript into the Rust. We built our caching engine fully in Rust, which is based on this data fusion, right? And then we built a SQL API, which is a connection point between BI tools and Cube, fully in Rust as well. And then we started to rewrite some of the data modeling framework pieces into the Rust as well. So I feel like Rust definitely helps us to speed up things, and on many areas, like even caching is obviously was a very obvious choice when we started, to build our own caching engine. We were thinking either let's do it in C++ or Rust, because you cannot do it in JavaScript, right? Obviously for performance reasons. But now as we started to adopt more Rust, Cube, and more core developers are very fluent in Rust, we're thinking of a lot of opportunities, especially around the data modeling piece, data modeling framework to rewrite in Rust. That will help us to speed up the query generation. I think SQL query generation is not usually the big problem in terms of the latency, but sometimes in some edge cases it can be. So, sometimes it can take like a second to generate, maybe like in 0.1% of the cases, but it's still, it still can happen. So that in that areas, we can use Rust to improve the SQL generation, and in general, just kind of transport wise, because you need to transform data still when you load it from Snowflake, kind of transform it in a different way and send it back to the tool that requested it. You're going to use some, CPU intensive kind of workload that can be rewritten in Rust to improve the performance. So we see a lot of opportunities to use Rust right now to improve the performance.
Being open source as the foundational component of the technical stack obviously helps with the adoption process, because you don't necessarily have to go through the whole sales cycle just to be able to test something out. It also simplifies the work of being able to incorporate the Cube product earlier into the development cycle, as well as throughout CI and into production. I'm wondering how you're thinking about the questions of project governance for the open source, as well as the product and business strategies, in order to understand what are those boundary lines for differentiation between when you want to use the open source, when you want to use the paid product, and how to manage that delicate balance of not cannibalizing the open source in favor of the business and not letting the business go under in favor of supporting the open source.
Good question. It's a question I get asked very often. I think, we try to be as honest as possible here, and I feel like transparency is a key regardless of what you're doing, because as long as you're being transparent and you sort of tell what is here, what is there, and what is on open source roadmap versus what is on a cloud roadmap, you manage an expectations of the community, and you're just being very honest, and it always pays off. So I think at the end of the day, it's features, right? Some of the features are going to be in open source, some of the features are going to be in commercial product, and there is no just other way around it, right? And by features, I think about like on a bigger scale, right? Like, because many software projects, they are like layers, they are onions. You got a bunch of stuff in the core, and then you put something on top of that. So some features maybe on top of that, they can go into cloud and commercial product, right? Some features may go into open source, and it's always many of these decisions, they like could be tactical decisions, but ad hoc. But as long as you're being honest and saying like, this features in open source, and we're not going to take them away, they're going to remain in open source. But these are features that are going to be in cloud. If you want these features, you can buy them or you can write them. It's open source. You can just create your own library, or you can another layer in that onion yourself. You have to maintain it, right? You'd have to write that code. The writing code is essentially, you spend some time, and someone needs to pay for the time, right? So by the end of the day, someone is going to pay for that work, right? But there is an option, and if the ecosystem is open, organizations, or like individuals, they can just develop their own like a plugin, so systems or layers around that. And as an open source maintainer, as long as you're very kind of open and transparent, saying like, here's core features, like the core open source product, here's extension points, how you can build your own stuff. If you want to build it, build it. If you don't want to build it, you can buy it in a commercial product. So that's sort of a framework we're trying to go with. And then you have to deal with a lot of tactical decisions. What exactly needs to go where?
And to that point as well of the technical decisions of what belongs in the open source versus not goes beyond just the question of whether it's in the open source versus the paid product, but also the question of whether it belongs in the scope of Cube at all, and whether it's something that maybe should be part of a completely separate piece of the technical stack or completely separate project. I'm curious, what are some of the tensions that you are coming up against as people are adopting Cube and they have their own concepts of what should be in scope versus shouldn't, or things that they are trying to make it do that it wasn't designed to do, and some of the potential directionality that influences as you continue the evolution of Cube, and just some of the ways you think about what is in scope, what is out of scope, and what is just pie in the sky thinking?
We have many of those, but probably one which is always follows us is sort of a BI and a visualization part of it. So in Cube, we have what you call a playground. Think about it, playground is, like a query builder interface in any BI tool. Like Looker, for example, I think call it Explore, right? When you have a bunch of measures, dimensions, usually on the left side, and then you have a chart on the right side, and you can either select and drag and drop things to build your chart. Every BI has it. So we have it and we call it a playground. The reason why we have it is that when you build your data model, you probably wanted to test your data model to make sure it's actually numbers are correct, how what kind of measures they have here, how we can play with it. So you need that tool. And we had that tool from very beginning. We recently did a big update to that tool. It now looks nicer. And it always it triggers the conversation. Oh, now Cube is a BI tool because we have it. And I don't think we're a BI tool because we have it. That's true. That's a big part of the BI, right? But I think that's something that we always been thinking at Cube a lot is do we want it to become a BI tool? I don't think we want. I don't think the vision for Cube is to be a BI tool. Are we going to have some of the features that might, kind of have an overlap with the BI? Yes, this query builder or playground is a good example because we just have to have it so people can test the data model. But I think that's an area where we try to keep the balance and we don't want to go into the BI world. We don't want people think about Cube as replacement for Tableau or replacement for Looker, because we're just not. We're not going to invest a lot of time in charts, in the dashboards, and all of that. We are focused on data modeling. We are focused on the metadata, things related to the metadata management, to the data model, to the governance in general. That's what we are. And I know that historically that's probably been a big part of the BI. So from that perspective, yes, we are close to the BI, but we're not trying to replace Tableau from the visualization perspective.
And in your experience of working on Cube, working in this space of the semantic layer, data modeling, what are some of the most interesting or innovative or unexpected ways that you've seen the Cube project used?
Because Cube in open source is very modular, so you can just take the pieces of the Cube out and try to use maybe only data modeling framework on SQL generation. So in open source, it's easier not to use everything together, but you can just use pieces of that. I saw organizations building experimentation platforms, internal experimentation platforms, with a Cube being a framework to model metrics. So they took our data modeling framework, they kind of changed it a little bit to their use case, and they just turned it into the metrics modeling framework for experimentation, A/B testing platform, which we were we never intended Cube to be that, right? But it was an interesting use case. So because of this modularity and embeddability, right? You can see a lot of different random use cases.
Another aspect of having the semantic layer, decoupling it from the business intelligence system, is, as we talked about, having the potential for multiple different data consumers, multiple different clients and access patterns. I'm wondering how you have seen that change the ways that data teams think about what it means to deliver data to the organization, and some of the ways that it has changed the organizational appetite for data exploration, given that it does open up the arena for having these multiple different bespoke use cases that don't necessarily all have to coordinate through a single tool.
Yeah, it changes how the data teams think about the data in a more way that they start to think about data as a product, and more closer to how software engineering team think about their work in general. So software engineering team, regardless if they're building a customer facing product or like some internal product, they think about it delivering some product, right? Like which is usually a piece of software, and then iterating on that product, like a changing, having a version system, so like delivering updates. So I think with having a semantic layer in place that can potentially offer multiple API for the data consumers, but also in general, was all the improvements around the data engineering workflow to be closer to the software engineering development cycle, code first, different environments, version control, all of that. It feels like more data engineering teams, they just generally think as a software engineering teams in a way of delivering products. In case of the data, it's a data products, right? So you can have it in a cube world, that would be cube view, right? The multidimensional data mart as your final data product. So now you have that artifact, that resource that you can give to your different data team. So you can give it to your analysts that can build a chart in Tableau. You can give it to the front-end team that can use it inside their front-end application. You can even give it to the customer. So we have our customers who are selling this to their customers. So they're like monetizing their data products essentially. So they're building some data sets and then like they exposing the SQL endpoint to their customers so they can just consume that, like that data. So I think that's sort of an interesting shift that I saw as many teams started to think about their work as a product work.
And in your experience of working in this space, building Cube, working with customers and end users and the broader data community, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
That's a very good question. I feel like data ecosystem went through a few interesting years, like to say the least, in the last 4 years or so. Like first we all went through the hype of zero interest rate, and a lot of people were thinking about data differently maybe back then, like that we needed more tools to solve for every small problem in the data stack. And now we all went to different side of the spectrum to like, we need less tools and, like we need to consolidate. I think at different times I saw in different trends. I think nowadays what I'm wondering about is that how data ecosystem and like data engineering ecosystem in general would work with AI and what is a crossover. So I go to some data conferences, like modern data stack conferences, and I don't see a lot of talks about AIs. Like it feels like like some talks are like a mandatory talks, like you have to talk about AI because like it's 2024, 2023. But I still don't see a lot of intersection between data and AI specifically. It feels like it's a little bit like two different worlds right now, even though the foundation of AI is data, right? You need to have data in place to run a good AI. So I think that's something that sort of, like maybe was a little unexpected when the all AI hype started. I expected to see more people from the data community lean into AI, which didn't happen.
And for people who are building their data systems, maybe they're trying to branch out to have more consumers of the data in their warehouse. What are the cases where Cube or just more generally a semantic layer is the wrong choice?
I think if it's a small organization and I would say like a 50 people org, and so there's first data hire, there are so many things that person needs to do from a delivering value, and maybe like do ad hoc reports is totally fine at this point, and just kind of writing SQL and Snowflake and getting all the foundational pieces in place, like have an ETL in place, making sure that you have a warehouse. Then you probably need to choose the first BI tool, and like which can be like a Metabase or Superset open source, because like at this stage you probably don't want to pay for like an expensive BI tool. I think at this point the organization still don't need a semantic layer. Now maybe once it gets to a point, okay, we have Metabase and we have more people trying to use Metabase in a self-serve way, how do we tell them what we have, what data measures, metrics they should look at? And at this point, the data team might have 2-3 people at least on a team. That maybe probably can be first time when an organization can think about semantic layer. But generally, as organization matures, right, as you get more data folks on the team, as you get more BIs in place, the need for the semantic layer would be bigger. So I would say It's definitely a wrong choice for like a 50 people company with one data hire. But as we go bigger, the need for that would increase.
And as you continue to build and iterate and evolve the Cube project and invest further in this semantic modeling space, what are the things you have planned for the near to medium term?
I think the big thing that we started to lean into is AI last year and this year. I think one of the use cases for Cube and for semantic layer in general is sort of how we go from natural language to SQL. And that's something that can have many different universal applications. It can be used internally. You can want to build a Slack bot. You can build an AI agent that incorporate some of the queries to your warehouse. But in general, when you need to have an AI agent that can execute queries against the warehouse, you probably need a semantic layer. So because if you think about that this way, like we have a lot of data already in a warehouse. If a human needs to access that, we need to write a SQL. It's going to be the same case for AI agents. If they need to access the data, they calculate some analytics around something, they would need to go and write a SQL to Snowflake. There is no way like we will take that all data, structured data out of this, we'll put it into context. Even if we do that, it's not going to work because like the LLMs, they're probabilistic. So they need to write a SQL. Now the question like how they can write a SQL is that can they generate a SQL query? I think they can because like they saw so many examples of the SQL queries out in the world, but they just don't know what exact SQL query to generate to the warehouse specifically. So the simplest approach would be like let's download the DDL like for your tables and just give it to this AI. The people did it, they did a benchmarks about it, and it only gives like a 17% accuracy or something because it just you don't have enough context, right? Like about your columns, about your information. So I think the solution here is to use a semantic layer or knowledge graph. So any way just to describe your ontology and describe your semantics, your data. So you give all that context to AI agent LLM now, and then now you can generate a really accurate SQL queries. And especially if you generate the SQL queries not directly to warehouse, but you generate them back to your semantic layer, that can act as an additional validation point. It even increases the accuracy, and also you can get all the your security access, cache and call the benefits on top of this. So what we're building at Cube now is a few things, but the first foundational thing would be an API endpoint where you can just send a tax query to Cube and saying like, hey, give me data essentially. And Cube will generate a SQL query on top of this, execute the SQL query, and do whatever the same thing we do for BI tool right now, but it's more like for natural language right now. And that's going to be very accurate because we're going to use the same data model we have already. And that can have a very wide range of applications in building chatbots and building AI agents and in having some sort of generative BI capabilities internally. So that's an exciting thing that we're working on right now.
Are there any other aspects of the Cube project specifically, or the overall space of the semantic layer that we didn't discuss yet that you'd like to cover before we close out the show?
I think that's it. I think that, like we covered a lot of things. Thank you. They were all great questions.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
That's a great question. I feel like the missing piece here is around the catalog that is closer to the business consumers and that is more friendly for the business consumers to consume. And will go deeper right now on this. I think with the catalogs, we got a really good development in the last several years. In general, with the first wave of the catalogs, Elation, Calibra, they kind of offer the tools to do the inventory of your data to create all these different descriptions of the data assets within your organization. And a lot of teams they successfully use it. And then we got a sort of a newer generation of these catalogs like Athlon. But I think the problem is that the catalog space is too big and too vague in terms of we can go down from like a low level catalog, like things like pipelines, airflow, jobs or something to up, like into the things that more like a business users care about, like in charts, dashboards, queries, all of that. So I feel what is missing is that a little bit more focus on that side of a spectrum that more like a data consumers care about. Is like what actual dashboards, how we can find the data, what are the metrics we have, like what are the charts we can use. And now when I think about that problem, I'm wondering why no one is using, maybe probably like someone is doing that already, but not why is I don't see products on the market right now that uses AI to do that, because it makes so much sense in terms of like discoverability in a catalog. And if I'm from a marketing team and a new hire, it would be good to go to some place and say like, hey, I just joined a marketing team, what dashboard should I look at, what metrics should I worry about? So it's just like a lot of things that AI can capture and a change here from the cataloging perspective. So I think here we'll see a lot of like good, interesting development soon. I'm sure someone is working on that right now. I just don't see it.
Absolutely. The overall catalog and discoverability space is evolving, but I do think it is still a little bit underserved. All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing on Cube and your perspective on the semantic layer and how it fits into the overall data platform, data ecosystem. It's definitely a very interesting problem space, and it's great to see the work that you and your team are putting into that. And I hope you enjoy the rest of your day.
Thank you. Thank you for having me today. That was a great conversation.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.